All right, everybody, it's Dr. J. We're going to be going over lipoproteins in this particular video. So let's talk about lipoproteins really quick as a brief reminder that lipoproteins share these common characteristics. So each of the lipoproteins are going to have a phospholipid outer layer, as you can see pictured here, where we get that double layer, keeping everything inside the lipoprotein that's supposed to be inside and keeping everything outside. This is also a way in which we can carry the lipid containing particles around the body. And you're going to see that we have lipids in the form of triglycerides as well as cholesterol, depending on which chylomicron that we are referring to. And then we're also going to have these proteins embedded. So the more protein that there is embedded, the higher density, and then the smaller the particle is. So that's where HDL, or high density lipoprotein, comes into play, where you can see that about 50% of that lipoprotein is protein, compared to the chylomicron, which is a really large lipoprotein that has a lot of triglycerides in it, a little bit of cholesterol, and a tiny bit of protein in it, because this is the first source of dietary lipids that get absorbed in the enterocyte to then come through and travel throughout the body and ultimately go up and get processed in the liver. So again, these lipoproteins have all these characteristics where we move from a larger structure to a much smaller, dense structure of lipoprotein. And as we go, you can see that each of these, as they get smaller, is going to decrease the amount of triglycerides and increase the amount of proteins. And then more specifically, you can see that LDL, which is low density lipoprotein, and HDL both have cholesterol. And this is one of the primary biomarkers that's measured when we go and get cholesterol panels done to look for our cardiovascular health risk. All right, so let's look at the actual process. So this is a quick review again of digestion, and this is the lumen, so along the small intestine, that lining. This blue cell here is your enterocyte. So again, those cells that line the small intestine. Here you would see the microvilli. So essentially, after we've broken down the triglycerides into the free fatty acids during digestion, right? We get the glycerol backbone, we get the 3 fatty acids or free fatty acids. We then are going to take them into the enterocyte. Remember that the micelle helps transport the large chain fatty acids, and then the short chain and medium chain fatty acids can just go into the enterocyte without any type of carrier. Now from here in the enterocyte, chylomicrons are actually created, and the ApoB48 protein, which I'll show you in a second, helps form the chylomicron in the enterocyte. And this chylomicron gets created because it then packages up the triglyceride to be able to transport it. So now this chylomicron can take the triglyceride and we can put it into the peripherals and travel throughout the body. Now, as I mentioned, the steps here is that chylomicron has these apoproteins that come in. So ApoB48 is actually what helps create the chylomicron itself. And then it's going to get proteins from HDL. So HDL is going to be providing the apoproteins, specifically the apoprotein C2 and ApoE. Now, I'm just going to, instead of saying APO, which is A protein, I'm going to just go ahead and say E, A1, C2, B48 moving forward. So that transition happened pretty quick. So again, unique to the chylomicron is the A1 as well as B48. And what happens is C2 and E from HDL are going to donate those, and we'll talk about why that's important. So this is important because ApoC2 is going to attach to the receptor along the adipose and the muscles in order for the triglyceride to take away from the chylomicron into the actual adipose and muscle. So here we are trying to basically get rid of these triglycerides inside the chylomicron. So C2 is going to attach the receptor on the peripheral tissues, whether it's adipose tissue or muscle. This allows the enzyme here to be activated, which is lipoprotein lipase, or LPL. So lipoprotein lipase allows that triglyceride to move from the chylomicron inside the actual adipose or muscle. And then this chylomicron is going to continue, and it's going to get a little bit smaller as it goes through this process of dropping off the triglycerides. I have to think of this as like an Amazon warehouse, where in the warehouse, we have taken all these pieces from the different areas of the world. We put it together in a package in your order, and then we put other packages together. And then this chylomicron or the Amazon truck is going to be kind of delivering all the packages along the way. So that's what the chylomicron is doing, where it's dropping off these triglycerides along the way. So as this process happens, the chylomicron actually gets uptaken in the liver, and in the liver is where we're going to then break it apart, and we form VLDL, or very low density lipoprotein. Now, very low density lipoproteins is going to carry the triglycerides that are actually synthesized inside the liver to the tissues. So a quick reminder is that chylomicrons are taking our dietary triglycerides, where VLDL is going to be taking the triglycerides that are actually created inside the liver. So here, once it leaves the liver, it's going to use the same kind of methods that the chylomicron did. However, if you notice, VLDL has the B100 and then C1 for the apoproteins. Now, same process where HDL is going to actually donate the ApoE and C2. So once we attach the other two apoproteins to VLDL, we can also then do the same process where C2 is going to attach to the receptor, and C2 is stimulating the lipoprotein lipase, or LPL, which allows that triglyceride to release inside the tissues. Now, once that's left over, all that happens is that we have cholesterol left. At this point, that's when we have this IDL, LDL kind of intermediate remnant. It's sort of whatever is left over from taking all the cholesterol from the liver and carrying it out to the tissues. Because we do need cholesterol in some capacity, it's just when it's in excess that it's bad. So in order for this now remnant to return to the liver, the B100 is what's going to attach to the liver and really uptake that particular lipoprotein back into the liver. Now, again, this step is important because in order for that liver to actually pull in the cholesterol and the triglycerides, it has to have B100 attached. Now, if we look at kind of the opposite way here, HDL is going to collect cholesterol from the various tissues or arteries, and it's going to actually carry it to the liver. Now, in the liver is when we are going to then have HDL provide that cholesterol away. It's kind of cleaning up the mess. If you almost, you got a bad package from Amazon, so you want to return it. That's what's happening. So HDL is a good thing because it provides the apoproteins to help us process and synthesize and transport the triglycerides and cholesterol, but it also helps clean up the extra excess cholesterol in our body. So let's just look a little bit more, because this is a huge piece that as dietitians, it's really important to understand the LDL and HDL relationship and the process of cholesterol, specifically metabolizing. So once the LDL is inside the liver, we have to process the leftover. So LDL actually gets broken apart and we have free cholesterol. So every single time that LDL is returning back to the liver, or the HDL is coming and kind of returning that cholesterol, we have these free cholesterol. From there, what happens is if we have too much cholesterol here, we are going to have to process it out of the liver because the liver can't handle as much. So what happens here is we then form this cholesterol ester and we stimulate that using HMG-CoA reductase. So this process here of using HMG-CoA reductase is creating a cholesterol ester. Now, some medications that are used to decrease cholesterol is actually inhibiting this. So therefore your body isn't like making as much cholesterol, because we can also get it in our diet, even though it's pretty small. It's the type of fats that we're eating that actually impact this process more than the dietary cholesterol that we consume. So from here, that ester is going to then transport out into the bloodstream, which then you're going to have this excess cholesterol running around, which then increases our risk of cardiovascular disease. So one thing to mention here is that this APO-100 is what actually stimulates the lysosome, because the lysosome can also come in here and break up the cholesterol. That's lipoproteins. That was really